Lesson 115, horizontal asymptotes. How do we find horizontal asymptotes of rational functions? So this particular right here that we're looking at is a rational function. So a rational function is when you have a polynomial divided by another polynomial. The top polynomial in the denominator, nope, that's called numerator. The top is called a numerator. And the bottom is called denominator. Yeah, I forget. Denominator. Okay, so the degree of the numerator, is the second degree. It's a quadratic, and the degree of the denominator is a linear. So it's a first degree. It's very important to know these degrees. So that's a second degree polynomial, a first degree polynomial. Okay. So now we're going to find horizontal asymptotes of the function. All right. If the degree of the blank is blank, then the degree of the blank, then the rational function has. Okay. What does that mean? Okay. What is it missing? If the degree of the numerator, if the degree of the numerator is greater, you see that it's a second degree. If the degree of the numerator is greater than the degree of the denominator, then the rational function has no horizontal asymptotes. So remember now, all you just have to, we can go more in depth as to why, but just remember if the degree of the numerator, the top is bigger power than the bottom, then it would not have a horizontal asymptote. How about when they have the same power? When they have the numerator and the denominator have the same degree power? If the degree of the numerator is equal to the degree of the denominator, because they are equal, look at x to the 1, 3x to the 1 power, then all you have to do to find the horizontal asymptote is to divide the numerator coefficient. What the heck, blank coefficient? The leading, they're called leading coefficients. All right, so in front of the x is called the leading coefficient, and in front of the bottom x here is the leading coefficient is 3. So then divide the leading coefficient of the top polynomial by the leading coefficient of the bottom polynomial, and the horizontal asymptote is equal to, you just have to set it equal to y. So y is going to equal to, y is going to equal to 1 over 3. Just divide the leading coefficients if they have the same power. Yes, makes sense. Well, you're like, well, but why? We can talk more about it, why this is true. Do I really want to talk about what this is? No, because we got to move. We got to keep going. All right, let's go. Keep going. Just, this is true. And the other case is that if the bottom has a higher power, you see, if the bottom has a higher power than the top, then this is what's going to happen. If the degree of the numerator is less than, so if the degree of the top is less than the degree of the denominator, then the rational function has a horizontal asymptote at y equal to 0. y equal to 0. Because the bottom is gonna grow so much bigger compared to the top. So the bottom is gonna get so much bigger that it's gonna go to 0. If you divide a small number by a big number, then it goes to 0. So the horizontal asymptote is gonna be at y equals 0. So those are the three cases for this particular when you have rational functions like this. I'm going to move on. Leave space. If you haven't copied all these this down, you might have to go to the website and copy it down so we can get going. Because it's a long lesson today. All right, moving on. What happens when you have something like this now? Where are the horizontal asymptotes when you have something like this? All right. So when you have a radical, a square root in this kind of function, when it's a fraction, we're gonna go like this to find the horizontal asymptotes. The top is still going to be 2x minus 3. And let's remember what's going to happen with this square root of x squared. Let's go back to this. This square root of x, well, the square root of 4 is just going to be 2. But let's go to square root of x squared. You have to really understand square root of x squared. And I'm really neglecting this plus 3 at infinity. Plus 3 is nothing. When you have $1 billion, $3 is really not much compared to billions. So at the very end. So here, square root of x squared, by definition, square root of x squared is equal to absolute value of x. Square root of x squared is equal to absolute value of x. And absolute value of x is equal to this. Piecewise, x, if x is for input values greater than 0. And it will equal to negative x for values that are less than 0. Okay, you can put it equal to one of them. Let's just put it for that one. So that's what you need to understand. So for input values that are positive, then it will just be x. And for input values that are less, it will be negative x. So then this is going to have to break down into two problems like this. And so it's going to go f of x equals that, and then f of x equals this. So for going to negative infinity, so for negative infinity, x is negative infinity for values that are less than 0. It'll be divided by, well, the square root of 4 is 2. The square root of 4 is 2. And then square root of x squared going to negative infinity will be negative x. And then plus 3 is almost nothing. That's, well, it just kind of compared to how big or how small bigness compares to be nothing. In this one here for positive, I'm looking now to the right, it'll be square root of 4 is 2, and then x, and then 3 is nothing. Well, why did I even ignore it for the bottom and not for the top? See, when it goes to very big numbers, so say x is negative a billion, x, then it will be a negative 2 billion, and then negative 3 becomes almost insignificant. So let me erase this, let me erase it here too. So this is going to be 2x over negative 2x. So what's 2x divided by negative 2x? What's this 2x minus divided by negative 2x? What's 2x divided by negative 2x? Negative 1. So it'll have a negative 1 horizontal asymptote. And then it will have, this one is insignificant. So 2x divided by 2x, it will be positive 1. So this one will be y equals positive 1. So it does have, whenever you have an absolute of the square root of an x squared, you would have two horizontal asymptotes. Let's see. So you have to remember that. So the limit as x goes to negative infinity, to write it even better, because these are limits actually, we're going to negative infinity of f of x, okay? Lim as x approaches negative infinity of f of x will equal to 2x over negative 2x. And this negative 1. So y equals negative 1 for that one. And then limit as x approaches infinity of f of x to the positive, it'll be 2x over 2x, which is 1. And so these are the two horizontal asymptotes. At y equal negative 1 and y equal to 1. This one's confusing as to why does this one have two horizontal asymptotes, and this one will not. And you're going to say, why does this one have two horizontal asymptotes if this is a square root and this one is a square root, and why would that only have one? Well, let's do this again. Okay, let's do it this way again. At infinity, this is growing so fast, x to the fourth is going to grow so fast compared to x, but it's this is a tough one. Hold on, let's go. F of x equals, and at infinity, these numbers become nothing, almost. And this 4x to the fourth is going to grow so much faster compared to x that I'm going to go ahead and also ignore this x. Oh, but yeah, I'm going to have to ignore that too. The problem is that this is not true with this. This is very particular to the square root of x squared is equal to an absolute value of x. But this one is not. Why not? Because it's x to the fourth. When we do that, let me see. Square root of 4 will be 2. Square root of 4 is 2. What is the square root of x to the fourth? Anybody? What's the square root of x to the fourth? Anybody? What's the square root of x to the fourth? Brian is falling asleep. What's the square root of x to the fourth? Yes?
X squared.
That is correct, Brian. Good job. That is correct. Everybody, there's an invisible 2 here, the index, and then you go 4 divided by 2 is going to be x squared. X squared is never negative. No matter what, x squared is never negative. That's why we don't do an absolute. Let's just, then this one is just going to be square root of x to the fourth is just x squared over 3x squared. So I'm not treating it like this. What's going to happen there? What can we do there? Cancel out the what? X squared is x squared. We have the same power, don't we? Yes or no? So because we have the same power, we just divide the leading coefficients. Yes or no? So it's going to be what? The horizontal asymptote is going to be at y equal to what? 2 over 3. Because we got the same power. When they got the same power, just divide the leading coefficient. So this one's going to be horizontal asymptote at y equal to 2/3. Okay, moving on. I think, yeah, let me go ahead and stop.